Good day, viewers all over the world. You are welcome to Toidel online class. We are still on that the topic set theory. Today we want to look at definition of terms. Definition of terms. That is, there are some terminologies that we are expected to be familiar with for us to be able to solve any problem under set theory. So the first one that we are going to define today is called the elements. The element of a set is called the element of a set. The first one that we'll talk about is called the element of a set. So what do we mean by the element of a set? What do we mean by that? The members of a set are often called the elements. The members of a set are often called the elements of that set. So if you have a set, all the list that we have in that set, the members of that set are often called the elements of the set. Another definition is when we talk about empty set. Empty set. Empty set. So what do we mean by empty set? Empty set. This is the set that has no elements. So please let's note that we can have empty set. In case of empty set, it's a set that has no elements, and it is denoted. It is denoted as phi, or just a curly bracket without any elements. That is how we represent empty set. Empty set is a set that has no elements. Please let's take note. It's a set that has no elements, and it is denoted as phi, or a curly bracket that has nothing inside. That is the definition of an empty set. Element of a set, as we have rightly said, they are just the members of a set. So that's the element of a set. Then the third one is called singleton set. Singleton set. Singleton set. Singleton set. So this is a set that has one element. So it's a set that has one element. One element. That is, e.g., when you have something of this nature. Please, I want us to see the difference. When it comes to empty set, we have just curly bracket, no elements here. But in case of singleton set, it's a set that has one element. There's one element here. This and this are not the same. This one has one element. It could be also, it can also be something like 1, or let's say A. So it has just one element. But in the case of empty set, it has no element. We represent it as phi, or we represent it as phi, or the curly bracket without anything inside the bracket. Then another definition is when we talk about universal set. Universal set. Universal set. In case of universal set, this is the set that has the set with highest consideration. That is, it is referred to as model set. That is universal set. It contains all the possible elements under consideration. So universal set contains all the possible elements under consideration. For instance, when we talk about set of natural numbers, it starts from 1, 2, 3, ... That is up to infinity. When you talk about set of natural numbers, they are the positive whole numbers. So they are sets. So, and they could be referred to as universal set because it consists of the digits from 1 up to infinity. So they are universal sets. So universal set contains all the possible elements under consideration. When we talk about set of integers, then it's an extension of set of natural number. It consists of negative, 0, and positive. And then let's take the last definition for today. Then we continue from there. Then the other definition that we are going to talk about today is equality of a set. Equality of sets. So two sets, say A and B. If you have two sets, A and B, the two sets A and B are said to be equal if A is a subset of B and B is a subset of A. So two sets are said to be equal if A, let's say two sets A and B are said to be equal, equality of a set. If A is a subset of B and B is a subset of A is a subset of B and B is a subset of A, it implies that A is equal to B. We are going to see examples on all this, but we are just trying to introduce sets, and these are some of the terms that we have defined. In our next video, we are going to continue from there. Thank you.